Hey everybody, we are going to go over section 3 today. Let me just pull up those notes really quick. Here they are. And we're going over properties of logarithms. We started going over this in section 2, and now we're going to start expanding on them, and not just what logarithms are, but also how to use them. So remember, we started to talk about this change of base. Remember, so if I said log base b of x could be the common log of x over the common log of b, right? We said that last one. So this time we're going to talk about this. So it says let a, b, and x be positive real numbers as long as a does not equal 1 and b doesn't equal 1. The change of base formulas say that. So there's 3 here, okay? So we can convert the log base a of x can be converted using any of these. So there's 3. So the first one we can use with base b, which is log base a of x. We can change it to a log base b, and we would say log base b of x over log base b of a. Okay, there's one way to do it. There's another way to do it, and this is with base 10, which is the one I showed you yesterday. So if you have log base a of x, we can say that this is really log base 10, or the common log of x, and log base 10 of a. And then the last one says we can also convert it by changing it to base e, where we would say log base a of x can equal the log base e, or natural log of x over the natural log of a. So any of these ways you can change the base, okay, of the same log base a of x. So if I was going to use a calculator to evaluate this, here is what I would do it. I would use the change of base formula, and the easiest way to do that is I would use the common log in your calculator. So I would say I'm going to evaluate the log of 20 and divide it by the log of 8, which would equal 1.4406 to the nearest 10,000th. All right, let's keep going. So now we're going to be talking about properties of logarithms, okay? So if a is a positive number, again, and a does not equal 1, where n is a real number, u and v are just positive real numbers as well. They exist. Here's our property. So remember, when we're multiplying logs, we can separate them by adding. So we can say the log base a of u times v is equivalent to the log base a of u plus the log base a of v. So when we separate the logs, we use addition. Same thing here. If I've got the log base a of u divided by b, to separate that division within the log, I'm going to use subtraction. So log base a of u minus the log base a of v, and those are equivalent. And then lastly, we kind of talked about this last time. If I've got log base a of u to the n power, this n can be pulled out in front, and we can say this is really like saying n times the log base a of u. So those are 3 properties that we'll be using a lot of, okay? So when we're talking, if the book or I ask you to expand a logarithmic expression, here's what that means, is we're going to use the properties of logs to rewrite complicated products or quotients or exponential forms into simpler, remember we turn products into sums, quotients into differences, and exponential forms into products. Okay. Okay, so let's go ahead and do example 1 together. We're going to expand the logarithmic expression. So we're going to make it longer, but it's going to be simpler. So I see a couple of things here. I see a multiplication between x and y to the 4th. I also see an exponent there. And I'm also seeing some division. So we know we're going to have to expand a multiplication product, a division, and deal with that quotient. So a couple of things we're going to do here. Remember, ln is just the log base e. So I'm going to go ahead and start with this. So in the top here, that's a product. So we're really saying that the ln of x plus the ln of y to the 4th. Okay, and then this division is really subtraction. So we're going to subtract ln of 2. And then I'm going to take one step further, and I'm going to deal with this power. And this is going to get rewritten as this 4 comes out in front, so we get 4 ln of y, and then these just stay here. So we've got this expanded, simpler expression of ln of x plus 4 ln y minus the ln of 2, which is really equivalent to this expression. Okay. So here is what we would do to condense an expression. So obviously it's the opposite, right? But we're going to use the properties again of logarithms for short, to rewrite the expression as a log of a single quantity. Okay, so condensing means it's going to get a little bit more complicated, but it'll be a single quantity. So if I look at condensing this expression here, we've got 3 times the log of x plus 4 times the log of x minus 1. So we have a couple things going on here. We're going to do this in a couple parts. So we're going to do these two together. First and foremost, I know that the product in front of that 3, I can really move it up here as an exponent. Same with this one. We're going to move it up as an exponent. So 3 log x is really equivalent to the log of x to the 3rd power. Remember, if there's no base on the log, it's just a common log. There's an invisible 10. And same thing, the 4 in front of this log here, we're going to move it up as an exponent. Okay, so that's simplified now. Now we still have to simplify this addition. So remember, addition, if I condense it down, turns into multiplication. So now we're really dealing with the log of x to the 3rd times x minus 1 to the 4th. And if you want to, you can make it one big product. And that's it. Okay, and that's it for notes today. We're going to go ahead and do all of our application examples and things like that in class. So I will see you in next class. Bye.